Okay, perfect. So remember, all we have to do here is rewrite log base 3 of 3 to 1/2, because the square root is a power, but it's a rational power, a fraction. And the power of 3 is 1, and the index is 2, so 1/2. One of the properties of the log states that when you will apply log to an exponential notation, the power goes in front as a factor, meaning it multiplies log base 3 of 3 in this case. Now, this is 1. How do I know it's 1? Okay, log base 3 of 3, let's say, is an unknown number. But this is equivalent to, as we discussed last time, 3 raised to y equals 3. 3 raised to y equals 3. So then how much is y? Well, y can only be 1. So then the final answer here is 1/2. Very good question. Was this in the homework?
Yes, it was.
Perfect. Anything else? Let me help with other things that you are the problems you have in the homework. Is there anything else? Did you encounter anything else in the homework that you need help with? Imani, Christy, any questions? Do you need help with anything?
No, I don't have any questions.
Okay.
I don't have any questions either.
Okay, so in that case, we'll continue with problems from 4.3. We already reviewed the properties. This is 4.3. It's properties of log, which were log of a product, log of a ratio. We just reviewed them a minute ago. Log applied to, let's say, a to a power a, and the change of base. Would you like to review any of this, or they are clear and we can go directly to problems? Can we go directly to problems, or do we need to refresh our memory on? I just reviewed them from the previous lecture, but maybe we need more. If not, we'll go to page 503. And we'll choose as many problems as we need to expand and condense. So we're going to expand and condense log expressions using the properties. That's why I'm going to include them here. So we are going to use these three properties and to expand and condense logarithmic expressions. And I'm opening the book on page 1, chapter 4. Okay, chapter 4, and I want section 4.3, and page 503. And let's choose. We will expand first and then condense. And then you'll see why we need to understand how to do it. Okay, so let's choose from 1 through 40, anything you desire. So the question is, use the properties of logs to expand. What would you like to start with? Any problem? And after we condense and expand, we're going to look at exponential and log equations. That's why we need these, to expand and condense. Anyone would like to choose?
Can we do 13?
Yes, let's start with 13. Very good. 13, we have natural log of e squared over 5. Perfect. Good starting point. Well, of course, I see a ratio. And I know there is log applied to a ratio. There is a property that allows us to expand this. All we have to do is remember that it's a difference. Log of the top minus log of the denominator. Now this is clear. We cannot do anything to natural log 5. But here I have a property that is the power rule, meaning I have to bring down 2 as we just did a few minutes ago. So 2 natural log e minus natural log 5. Well, natural log e is the same thing with log base 3 of 3, which I know it's 1. How come? Because the base is e. So log base a of a is always 1. So when we apply log to the number that is the same, happens to be the base, the answer is always 1. A to the first power equals a. So then the final answer is 2, because it's 2 times 1, minus natural log 5, and this is it. Any questions on this problem? Are we okay with this? Please give me a sign, a reaction, anything, so I know that you're here with me. Okay, let's move on to another example. Anyone would like to choose? If not, I will.
Can we do number 26?
Of course. Of course. Let's look at number 26. Good. 26. Very good. Log base 8 of 64, everything divided by the square root of x plus 1. Very good. Again, it's a ratio, so I have to apply the quotient rule, which means log base 8 of 64 minus log base 8 of the square root of x plus 1. Yes, I have to change 64 into 8 squared. And I have to change the square root of x plus 1 into x plus 1 raised to 1/2. The square root means power 1/2. So then I continue. Log base 8 of 8 squared. Again, I have to use this power rule. The same thing here, minus log base 8 of x plus 1 to 1/2. And I have to use the power rule. Good. So then I have 2, but log base 8 of 8 is how much? How much is log base 8 of 8?
1.
Exactly. Always. Minus 1/2 log base 8 of x plus 1. And this is it. So let's go back to the properties for a moment. There is no log applied to a sum or a difference. This is carved in stone. No one can touch it. We only have 3 rules. Log applied to a product, quotient, and power. We do not have a rule that simplifies log of a sum of terms or log of a difference of terms. This is it. So this is the expanded form applying the three properties of log. No one can simplify log of a sum. Good. Let's see what else we want from here. Anything else you want before we move on to condensing, going backwards, in other words. If you don't choose, I will. Anyone else?
Can we do 33?
Of course. So let's look at 33. 33. Log base b of the square root of x times outside y cubed, everything over z cubed. Perfect pick. Thank you. I have to start with a quotient. So then this is log base b of the square root of x times y cubed. You can put it in parentheses if you want, minus log base b of z to the third. This one is very easy. The only thing I have to do is just move 3 in front. This one is easy as well. It's a product. Log applied to a product is the sum of logs. So let's take a look. Log base b of the square root of x plus log base b of y to the third minus 3 log base b of z. And this is done. This one can no longer be simplified. But this is power 1/2 that goes in front. This is power 3 that goes in front. And this is it. We exhausted all properties. We started with a quotient. Then we realized that this was a product, so this is a sum of logs. And then we realized that every factor here had a power. The corresponding power had to go in front. Any questions on this problem? Okay, is there anything else we want to work on before we go back to backwards to condensing? Anyone? Is there anything else we want to work on? Can we move on to condensing then? So see all these examples here, everything is condensed in one log and the number in front is 1. So now we are given all these from 41, all sorts till 70, and we want to bring them back to this level. So all this has to be changed into one single log with 1 in front and whatever expression we come up with. So from here, the problems we chose, like 33, for example, from here, we wrote this. Now we are given this to go back to where it came from. Okay, so let's choose anything you like from 43 through 70. So this time we're going backwards. We are condensing into one log with coefficient 1 in front, nothing else, not 1/2, not 3, not 7. Coefficient 1 and apply to whatever expression we come up with. So 43 to 70, anything. And now we want to condense. Anyone would like to choose?
Can we start with 43?
Of course. Let's start with 43. So 43 is natural log x plus natural log 7. If it's a sum, we know it comes from the product. And that's it. If I have natural log of 7 times x, that equals natural log x plus natural log 7. Is this okay?